In this problem, I am pulling point A here down at 2 meters per second. And what I want to find is how fast the block at B moves upward based on that downward motion. Okay, so again, what I need to do is I need to start by defining each position of point that's moving. And the points that are moving are A, C, and B. Now I'm going to use basically the pulley here because, again, this is a fixed distance that once I take a time derivative will go to 0. So I'll just take the center of the pulley for point B. So I have that position, center of pulley C, and then this distance A again, and I'm going to call my datum right through pulley D. Again, because all of these distances over the pulleys are fixed. Okay, so when I take a time derivative of them, they go to 0. So now I'm going to write the length. I have two cables here. I've got this top cable and this bottom cable. So the top cable is basically, if I start over here, from here to here is C, and then from here back up to here is another C, and then from here to here is A. So I have 2C plus A, basically for the length of cable 1. The length of cable 2 is, again, starting the top here, go down, that's SB, and then from here to here is the difference between SB and SC. So I have SB minus SC right here. Okay, so again, I'm trying to find the relationship between A and B. So what I'm going to do is I'm going to add these equations together to get rid of SC. So essentially I take the bottom equation times 2 and add them together. So I have 2SC minus 2SC when I add them together. Okay, so I'm going to take the bottom times 2. That leaves me 4SB, right? Because I take 2 times SB and 2 times SB here. So I get 4SB, okay, plus the SA equals L plus 2L, which is what I have here. Okay, so now I have a relationship between the position of A and the position of B. Now I'm going to take a time derivative of that to get to the velocity. So the velocity of SA is VA, the velocity of SB is VB, so I have 4BV, and the derivative of the length of cable 1 and length of cable 2, those lengths do not change. The total length is unchanged, so the time derivative of those equals 0. So I'm left with this relationship between the velocity of A and the velocity of B, knowing that the total length does not change with time. So now plugging in 2 meters per second for the velocity of A, I can find that the velocity of B is, I actually get negative, okay, which means that the position B is actually getting smaller, meaning that position is moving upward at a half a meter per second. So again, just figure out the position of each moving piece, and then using those positions, figure out the length of each cable, and take a time derivative to get to velocity, and then solve.